Today we're talking about significant figures. Significant figures are those digits in a measured number that are known with certainty plus the first uncertain digit. The key to understanding significant figures is that we have a measuring instrument and we obtain a measured number. You do not have significant figures for counted numbers such as money or counting people, but you do have significant figures anytime you use an instrument to measure something. So those digits in a measured number that are known with certainty plus the first uncertain digit. So we are going to look at significant figures with 3 graduated cylinders. Before we do that, though, let's remember that significant figures tell all about an instrument. They tell how an instrument is calibrated. It is the calibration of the instrument that we know with certainty. Calibration is where the marks are on the instrument. The marks, the lines on the instrument, are calibration marks. And those marks on the instrument are what we know with certainty. Then we guess at the first uncertain digit. All of those, the certain and the uncertain, are significant figures. So significant figures all about an instrument. We have 3 graduated cylinders. Each of these is calibrated differently. Let's look at this graduated cylinder and determine how it is calibrated. This graduated cylinder is calibrated every 1/10 of a milliliter. Each of these lines is 1/10 of a milliliter. So we say it is calibrated in tenths. That is what we know with certainty. We are going to guess at the hundredths. So what we are guessing at is our uncertain digit. So it's calibrated in tenths and we guess at hundredths. We'll take a straight edge. It could be a ruler, straight, anything that you have, a card stock, which is what I have. And we're going to look at the bottom of the meniscus. Remember, when measuring in a graduated cylinder, you read the bottom of the meniscus. So we're putting our straight edge right at the bottom of the meniscus. And you can see that in this instance, we are right on the line. So let's determine what that line is. This is 1, this is 2, and remember each of these is a tenth. So this is 2 1/10, 2/10, 3/10. So with certainty, we know the measurement is 2.3 milliliters with certainty. But that is not the correct significant figures. We have to tell the reader that this instrument was calibrated in tenths, and I could have put a number after if it had not been exactly on the line, but because it is exactly on the line, I put a 0, telling the reader that I am exactly on the 2.3 line. I could have determined if it were above or below, but it is exactly on the line. So my measurement is 2.30 milliliters. In this instance, we have the 2 digits that we know with certainty. These are our certain digits. And then we have the uncertain digit. So we say there are a total of 3 significant figures in this number. Let's go to the second graduated cylinder. We see that in the second graduated cylinder, each of these calibration marks is actually a 1 milliliter mark. So in this instance, we're going to use our straight edge again. And once again, it appears that we are right on the line. So, which line is it? This is the 10, 11, 12, 13. It is the 13 milliliter line. How do we tell the reader of this number that this instrument was calibrated in ones and we guess at the tenths? We put a .0 And this tells the reader we know with certainty the ones place. These are our certain digits, and the 0 then is our uncertain digit. Now let's go backwards for a minute, looking at this number and forgetting we have the picture next to it. If I were to just see this number, knowing what I know about significant digits, I would say, this is my uncertain digit, this must be how this instrument was calibrated, so this particular graduated cylinder was calibrated in ones. And as you know, it was calibrated in ones. The final graduated cylinder that we have is a very unprecise or imprecise instrument. It is actually calibrated in tens. So if it's calibrated in tens, that means that we will be guessing at the ones place. So it's calibrated in tens, guess at ones. Once again, take our straight edge and draw our line, and yes, once again it is on the line. So we are going to find out what line it is on: 400, 410, 420, 430, 440, 450, 460, and it is on the 460 line. This situation causes a little bit of a problem with 0, because the question is the 0 significant or is it not significant? Well, following our rule for significant digits, those digits in a measured number that are known with certainty. So what do we know with certainty? We know with certainty that this is the 60 line. We know with certainty that this is the 410, 450, 460 line. We know with certainty this 6 is correct. What we cannot do is we're saying that it's on the tens line, the 460 line. It's not above it, it's not below it, we're saying it's exactly on it. So we are going to say yes, that 0 is significant. If we had been a little bit above, a little bit below, we would have called it 459 or 461. But it is exactly on the line. So since we are calibrated in tens, we're guessing at the ones, we must put the decimal to show that this ones place is significant. And then don't forget your unit. Alright, going back to total significant figures, we failed to do that on the second one and on this third one, so let's count again. Because this decimal is present, that 0 is significant. So this is a total of 3 significant figures. And the same thing applies here. 13.0 milliliters. Once again, because this 0 is present and there's a decimal, then we say also 3 significant figures. You'll want to refer to your rules for 0 in determining whether or not 0 is significant, and you should have those in your notes. Using those rules, let's give the number of significant figures in each of the following. Because there is not a decimal on this number, we say that these zeros are not significant, the 6 is significant, so that means there's 1 significant figure. In this measured number, the 2 zeros that are between the non-zero digits are significant, so that's a total of 4 significant figures. In the third example, we have 2 zero scenarios. We have the 0 after the decimal, which is significant. We have the 2 zeros before the decimal, which are not significant. Now we have to remember, significance and importance are different in chemistry. Yes, these zeros are important. This 0 holds the place value. This 0 is important to indicate for sure this is a decimal rather than a stray mark. However, as far as significant figures are concerned, they are not significant. So that means we only have 2 significant digits. For these 2 examples, we're actually going to be using the rules for calculations. Refer to your notes. You'll find that in the rules for calculations, when you are adding or subtracting, you're going to look for the least precise. Most of the time, that indicates the number behind the decimal. Sometimes you don't have a decimal to look at. In this example, we do. So let's add these numbers together, lining up our decimals, 9.203 plus 6.2, and we get 15.403. We have one place behind the decimal, 3 places behind the decimal. We're only going to have one place behind the decimal in our answer. The 0 does not make a 4 go up, so the answer then is 15.4. The rule for calculations in multiplication or division deal with total number of significant figures, and your answer should have the least. So this has 4 significant figures, this has 2 significant figures. That means our answer has to have the least significant figures, which in our case will be 2. So I'm going to use my calculator, and I prefer the TI-30XA. So our TI-30XA, 11.23 times 5 equals, and we get 56.15. 56.15 should only have 2 significant digits. These are my 2 significant digits. A 1 does not make a 6 go up. That means my answer is 56. In the last examples on this page, we're actually going to go backwards, similar to what we did on the example number 2 above with the graduated cylinder. And we're going to determine how these instruments were calibrated as a reader of the number. And so we have, in this example, 4 significant figures, and knowing our rule for significant figures, we know that this is our uncertain digit, which means this is where our instrument was calibrated. There were calibration marks at the 10th of a milliliter. So we say this instrument was calibrated in tenths. The last instrument is obviously very precise. It has 4 places behind the decimal. That means the very last digit is our uncertain digit. The digit before the last digit is our last certain digit, which is how the instrument is calibrated. And remembering place value, tenths, hundredths, thousandths, 10,000ths, that means that we have an instrument that was calibrated in thousandths.